A new object, previously unknown and entirely unexpected, had entered our solar system. Not a comet or asteroid behaving within the normal limits of celestial mechanics, but something entirely different. The announcement marked a pivotal chapter in the ongoing exploration of the cosmos, raising fundamental questions about the nature of interstellar travel, cosmic anomalies, and the very fabric of our understanding of space. Before we start, smash the like and subscribe for more updates. The object had first been detected by an array of deep space telescopes, particularly one stationed in a high Earth orbit whose instruments captured a peculiar reading in the Kuiper Belt region. At first, the signal was dismissed as noise, an anomaly caused by sensor interference or background radiation. But as more data accumulated and was cross-referenced with international observatories, the existence of a tangible physical entity became irrefutable. What made this discovery so astounding wasn't merely its trajectory or composition, but its behavior. Unlike traditional celestial bodies, which typically follow predictable orbital patterns under the influence of gravity, this object displayed movements inconsistent with known gravitational influences. It slowed down at times, accelerated at others, and even changed direction ever so slightly, subtle deviations that no naturally occurring object could plausibly exhibit on its own. The scientific community, already alert from previous interstellar visits like Oumuamua, quickly redirected their resources toward tracking and analyzing the newcomer. However, this wasn't just another elongated rock tumbling through space. This object emitted a faint but consistent electromagnetic signature, a pattern that deviated from the random emissions typical of cosmic debris. It pulsed almost rhythmically, suggesting internal activity or even an artificial structure. Its albedo, the measure of reflectivity, also baffled scientists. It absorbed an unusual amount of solar radiation while emitting infrared signals in precise bursts akin to modulated data packets. Such signs strongly hinted at technological sophistication, prompting deeper questions about its origin. What makes this discovery so electrifying is not merely the physical nature of the object, but the way it challenges conventional boundaries in astrophysics. For decades, the prevailing assumption has been that any object entering the solar system must be driven purely by the laws of motion and gravity. But here was something, or perhaps some construct, that appeared to exert its own influence over those very laws. The fact that it maneuvered at will through space brought a new layer of complexity to the investigation. Not only was this a visitor from beyond the heliopause, it seemed to be under some form of intelligent control, or at the very least, built to respond dynamically to its environment. Michio Kaku, long known for his deep fascination with higher civilizations and multiverse theories, approached the phenomenon with the gravity it deserved. He emphasized that humanity might be standing on the threshold of a first contact, not necessarily with sentient beings, but perhaps with an artifact, a probe, or an autonomous vehicle sent by an advanced civilization light years away. The implications are staggering. If the object is artificial, it suggests that interstellar exploration is not a dream confined to science fiction, but an active reality in other parts of the galaxy. And if other civilizations are capable of sending autonomous technology across interstellar distances, then humanity must recalibrate its own aspirations within the cosmic timeline. The object's trajectory has been closely monitored as it continues its journey inward. Its course does not intersect directly with Earth or any of the major planets, but its path through the solar system seems purposeful, as though it's following a carefully mapped route. Advanced simulations suggest that it will make a close pass by Jupiter's magnetosphere before slingshotting into a higher orbital plane around the Sun. This maneuver, mimicking techniques used by human spacecraft to gain momentum, raises further suspicion that this object was designed rather than formed naturally. Such behavior forces scientists to consider what its mission could be. Is it a passive observer simply collecting data, or is it part of a broader long-term reconnaissance effort? Notably, the object's apparent deceleration as it neared the Sun contradicts the behavior of natural interstellar objects, which usually accelerate due to solar gravity. Instead, this deceleration implies a controlled entry, a braking mechanism of some kind that leads to provocative speculation about propulsion. Unlike chemical or nuclear-based systems familiar to Earth-based technology, This object might be employing a form of propulsion entirely unknown to current science. Antimatter engines, quantum drives, or even manipulation of space-time itself are not out of the question in such discussions. While still hypothetical, the very presence of such an object makes the once fantastical seem suddenly plausible. Astronomers have also noted that the object emits periodic bursts of energy detectable in multiple frequencies, including the radio spectrum. The patterns, though not yet deciphered, seem far too structured to be random. Early theories range from it being a self-calibrating device, adjusting to the conditions of each planetary sphere it passes to it, possibly transmitting data back to its origin point. If the latter is true, then somewhere perhaps dozens or even hundreds of light years away, another civilization is receiving information about our solar system right now. It may be watching the signals, analyzing our star, measuring planetary atmospheres, perhaps even detecting artificial electromagnetic noise emitted from Earth itself. This introduces profound philosophical and ethical dimensions. Are we being watched not in the paranoid sense often portrayed in popular media, but in the broader context of cosmic observation? Just as we deploy probes to Mars, Saturn, and the edge of our own solar system, perhaps other civilizations eons older and technologically superior are quietly studying young planetary systems like ours. Such behavior would be consistent with a non-invasive strategy, a cosmic survey rather than an act of conquest. And while we might yearn for direct contact, perhaps the message embedded in the very arrival of such a probe is that patience, caution, and understanding are vital prerequisites before communication. The implications also stretch into the realm of theoretical physics. The presence of a potentially artificial interstellar object challenges our understanding of the constraints of the universe itself. Traditional theories suggest the vastness of space and the speed of light pose near insurmountable barriers to interstellar travel. However, if this object truly hails from another star system, and if it is indeed artificial, then those barriers may already have been overcome by another species. That in turn reinvigorates questions about warp drives, wormholes, and the feasibility of faster-than-light travel. It reignites conversations around the Kardashev scale, a method of measuring a civilization's technological advancement based on its energy usage. A Type 1 civilization capable of harnessing planetary energy is where humanity might reach within a century, but a Type 2 or 3 civilization with control over stars or even galaxies could plausibly send exploratory vehicles across interstellar distances with ease. Equally compelling is the psychological impact such a discovery has on humanity. For centuries, the human mind has occupied a lonely place in the universe, aware of the stars, but divorced from them in a meaningful way. The idea that we are not alone, even in the passive presence of an alien artifact, redefines humanity's self-perception. Suddenly, we are part of a greater cosmic story, not the sole protagonist, but one chapter among many. This alters the conversation in classrooms, research labs, policy chambers, and religious communities. It asks us to reconsider how we approach life, progress, and unity as a species. The implications for astrobiology are no less significant. If this object is the product of a life-bearing civilization, then life must not only be possible elsewhere, it must be prevalent enough for civilizations to arise, mature, and reach out across the stars. That changes the Drake equation, which estimates the number of intelligent civilizations in our galaxy. A single confirmed artifact would tip the equation's answer from speculative to empirical. It would no longer be a question of if, but how many and how far apart. From a technological standpoint, this object becomes a case study, a Rosetta Stone of engineering prowess. Scientists and engineers are already devising potential mission concepts to intercept the object, using high-speed propulsion and autonomous AI-driven probes. If a rendezvous could be achieved, the benefits would be immeasurable. Detailed analysis of its material composition, structure, and functionality could advance human science by centuries in a single moment. It would be akin to a Stone Age society stumbling upon a satellite from orbit, an encounter with knowledge so advanced it verges on magical. At the same time, governments and space agencies around the world are treading carefully. The global community understands the delicacy of this event, the potential for misinterpretation, Overreaction or even militarization of the discovery hangs in the balance. There is a growing consensus that this moment must not be consumed by paranoia or secrecy. Instead, transparency, international collaboration, and ethical stewardship must guide humanity's response. After all, if we are being watched, our reaction is likely being observed as well.